Hello, this is Dr. Mears. Today we're going to be going over the Formative Performance Review 1. If you don't have a copy of this, it is on our Schoology page. If you open the Unit 3, Sets and Probability, it's the only document that's there. So you can print it out or even maybe have it on the screen. You can do half video and then the other half the actual problems. So here we go. Number 1, there are 7 months that have 31 days. A month is randomly chosen. What is the probability that it will have 31 days? Now this is just a standard probability question. I want to make sure that you know how to set up a probability. So we're going to do the probability that we have 31 days equals, remember fraction bar. The bottom number are the total number of outcomes that can happen. We have 12 months in a year, so that's where 12 goes. Now, the number on top is how many outcomes we have. We know we have 7 months that have 31 days. So the 7 is going to go on top. And there's your probability, 7 out of 12. And you can leave it just like that. Number 2, there are 30 students in math class. 20 of the students have studied probability, 14 have studied set theory, and 2 people have studied neither. Now this is from page 348, number 4, from some of our practice problems you may have read. What I have to say about this one is I changed some of the questions so that they better align with the formative. I wanted you to understand how I ask questions differently. So I'm taking the information and changing the questions. The first thing that we have to do is do a Venn diagram. So let's do a Venn diagram. Box. Now I have probability and set theory, so I'm just going to have 2 circles, one for probability, then I'm going to call P, one for set theory, then I'm going to call S. Those look very uneven. I have 30 students in math class, 20 study probability, 14 set theory, and 2 neither. Please notice we always do start in the middle, but I don't see that we have both here. So we're not going to be able to start in the middle this time. This is a little bit different. So let's start on the outside. We know that 2 have studied neither, so let's start there, 2. Now, if we did start in the middle, we would put whatever number that took both probability and set theory. But since we don't have that number, that's our unknown. I'm going to write X. Then in my probability, I know that 20 study probability, but I can't write 20 here because this 20 also includes this X, so I would have to deduct out whatever both was. Since both is our unknown, I'm going to put 20 minus X here. Now 14 have studied set theory, which is this whole entire circle, and again it takes into account this missing number. So when I find my X, I'm going to have to deduct it out of 14 as well. So we have some unknowns here. I bet you the first question is going to be to find that both, how many took both. So let's see. Find the number of students who. Now, be careful of these questions because they're going to say find the number and find the probability. This one says find the number. So I don't need to set up any type of probability. So please be careful when you're reading. So the number who studied both topics. So here you go. I have to find my X. This is how you find it. We know that if we add up this piece, this piece, this piece, and this piece, we're going to get a total of 30 students. So let's add all of those little pieces up. 20 minus X. Plus X, plus 14 minus X, plus 2. And that's going to equal 30. I'm going to add all of my numbers, 20, 14, and 2. I'm going to combine my variables, negative X, positive X, and negative X. These actually cancel out, so I'm going to get rid of them. 20, 14, and 2 is going to give me 36. And so I'm going to cancel those out. And then what I have left is minus X. I'm going to bring it down and bring down my equals 30. I go about solving this, minus 36, minus 36. Bring down my minus X, that's really negative 1X, equals negative 6. Divide out my negative, so I get X equals 6. So studied both 6 students. So now that I have my 6 students, I can go back and fill my diagram in. So we know this right here is going to be 6. 20 minus 6 is going to give us 14. And 14 minus 6 is going to give us 8. Let me erase this a little bit. So this was X, but now X is 6. So we know 14 students just took probability, 6 students took both, 8 students just took set theory, and 2 took neither. And if you wanted to check to make sure that this added up to 30, you would just add each of these little pieces, and they do. There's my phone. Everyone's going to hear that. Let's do part B. Studied exactly one of these subjects. So exactly one could be probability or set theory. So probability of exactly one equals, so, oh, not the probability. See what I just did? The phone rang and I got all, who was it? We're actually finding the number. So remember that. We're going back to the number. So the number who studied exactly one. So we have 14 who studied just probability and 8 who studied just set theory. And 14 plus 8 is going to be 22 students. How about the number for part C, studied set theory but not probability? So probability, set theory, not probability. So that's basically just set theory, and that's going to be 8. And that's that number right here. 8 students. Okay. Next, let's look at the set of directions. Find the probability. So C, please realize we're switching between finding a number of students and finding the probability that a student randomly selected will be doing these things. So please be careful what the question is asking. So now that we're setting up probabilities, we're going to be setting up fractions. So probability, both topics. Remember probability, the bottom number is the total number of students here. This is not condition. This is not conditional, so 30. Both, we're going to look up at our both, and we found that was 6. So that studied both is 6 out of 30 students. And probability, studied exactly one. Again, set this up. Number on the bottom, total number of students. How many exactly one? Well, we have that from a previous question, which is 22. We got the 22 by adding just probability and just set theory, so we can write that number in 22. Okay, let's go to the next page. The next page says, studied set theory but not probability. So probably set theory, not probability. So let's go back and look at our diagram. So studied set theory, not probability. So it's just set theory here. So we're going to set up our fraction. 30 was on the bottom, and I believe 8 was just in that little part of that circle. Next, studied at least one. So probability at least one equals 30's on the bottom. Let's go and look to see how many studied at least one. And remember, at least one can mean one, the other, or both. So now we're doing one, the other, or both. So we're going to have to add 14, 6, and 8 together to get our numerator here. So this number is going to come from 14 plus 6 plus 8. That's that number right there, little arrow. So that's going to be 28. So the probability that a randomly selected student is studying at least one subject is 28 out of 30. And that makes sense because there's 2 not studying anything. And the last one for this one, studied probability given that the student studied at least one. So here's our given. So probability given at least one. So our denominator is going to change here. The denominator is going to be how many ever students took at least one. And so we actually calculated that in this one, so it's going to be 28. Now we have to say studied probability, and be careful of this because this means studied probability, they could study just probability, or they can study set theory as well as probability. So it's basically the whole circle. So let's see how many people took probability. So we're looking at is this whole circle here. This is the probability circle. So we have to add the 14 and the 6 together. 14 and 6 is going to give us 20. So we got this by adding the 14 people who just took probability and the 6 for the people who took both. So this is at least one Given at least one, they took probability. Number 3. In a youth camp, each participant must take part in at least one of the following activities: chess, backgammon, or dominoes. Of the total 55 in the camp, 25 participants participated in chess, 24 in backgammon, 30 in dominoes, 15 in both chess and backgammon, 10 in both backgammon and dominoes, and 5 in both chess and dominoes, and 2 in all 3. Yay, they gave us all 3. This is from page 350. It is number 3. Again, I took the example. I changed some of the problems a little bit. So if you go back, there might not match up. You do, however, have to make a Venn diagram here and in the book. So let's set up our Venn diagram. We're going to have 3 circles. We're going to have a circle for chess, C for chess. We're going to have a circle for backgammon, and we're going to have a circle for dominoes. And I'm just going to abbreviate CBD. So I set my circles up, and when I set my circles up, I usually just go clockwise labeling them: C for chess, B for backgammon, and D for domino. So I usually just go this way. I usually start it this way. Okay, so let's start. You got it, in the middle. 2 are in all 3. So here's the 2. So that's a check. Okay, let's go. And now I'm just going to work up my way back. 5 is in both chess and dominoes. Okay, so let's look. Chess, dominoes. So that's here. However, of those 5, 2 are also taking backgammon. So that leaves 3 in this little spot. So now if I look at this space, 3 plus 2 is 5 in both chess and dominoes. It just split because some of them took 3 altogether. All right, that's out. 10 in both backgammon and dominoes. So let's see, backgammon and dominoes, there's 10. But again, of those 10, 2 took all 3. So that leaves us with 8. So 8 goes here. 15 in both chess and backgammon. But again, of those 15 in chess and backgammon, 2 took all 3, so that leaves 13. Out. Now we have 30 in dominoes. So we're going to go the domino circle, and notice here's the domino circle. It has the 3, the 2, and the 8. So we have to be careful. We have to do a little math over here. So 30 took dominoes minus the 3 who took chess and dominoes, minus the 2 who took all 3, and minus the 8 that took dominoes and backgammon. And what we're going to have left is 17. So there's a 17 here. Out. 24 in backgammon, again 24 in backgammon, but if we look at the backgammon circle, we have 13, we have 2, and we have 8. So that's only going to leave us with 1 that just took backgammon. And 25 that took chess, but again, if we look at our chess, we have 3, 2, and 13 in our circle, which leaves us with 7 that just took chess. I kind of like to figure out this neither part. So if we add up all of these numbers and subtract from our 55, we're going to see how many took neither. So I'm actually going to do that. So we have 55 minus, and we add all these little pieces, subtract them out. 7 minus 3 minus 2 minus 13 minus 17 minus 8 minus 1 equals... So let me make sure I have everyone. 7, 3, 2, 13, 17, 8, and 1. Yep. And that's going to leave us with 4 that take nothing. None of them. So that's 4 on the outside. All right, I have everybody, so we're ready to go and answer our questions. Let's see what they're looking for. Part A says find the number of participants. So this is not probability. It's a number. Not taking part in at least one. At least one. So at least one, those are all these circles. So number of participants not taking part in at least one activity. So that's our 4. So 4 participants. I like to label everything. It's not a probability, it's the number of. Next. Find the probability of a randomly selected participant taking part in at least one. So here's where it changes to probability. Probability of at least one. We're going to have a fraction. The number on the bottom are the total participants. That's 55. At least one. Taking part in at least one. We have to find this number. So this is taking part in at least one. That's not the 4. This means we have to add up all of these numbers inside. And when we add up all of these numbers inside, 7 plus 3 plus 2 plus 13 plus 17 plus 8 plus 1, we get 51. So 51 are taking part in at least one out of 55 gives us our probability. Next, in part C, find the number of participants taking part in chess. Now this is the whole chess circle. It doesn't say just chess. It says in chess. So you have to go up here. We want this whole circle because I don't care if they take 2. I just want to know they're taking chess. So the number, so we're going to put 7 plus 3 plus 2 plus 13. So I'm adding up everybody in that chess circle, and I'm going to get 25 participants. Next, find the probability that a randomly selected student participates in chess given the participant is taking part in at least one. So here's our probability again. So we're doing chess given at least one. So we're going to be changing the denominator. This is going to equal at least one. We already found was going to be 51. And participating in chess, we found that's actually 25. So that's 25 out of 51. And lastly, number 4, just a plain Venn diagram, nothing else given, just A and B. We see overlaps. We need to find that A and not B. So we have to shade A and not B. So here's A circle. Here's the B circle. So we can't have the B. So we're just going to shade A and not B, and that's your answer. I hope this helped. This has been Dr. Mears. Study. Good luck.